In the third and final review for the Chem 119 final, we are going to discuss the last chapter. Alright, so the first thing you need to remember is one of these here will be on the test. I'm not going to tell you which one, but you need to be able to know examples of some of the proteins and what classification they are. So denaturing. Denaturation involves the disruption of bonds in the secondary, tertiary, and quaternary protein structures. They heat inorganic compounds, but if you heat it up, they break apart the hydrogen bondings and disrupt the hydrophobic interactions. If it's acidic or basic, they break the hydrogen bonds between the polar R groups and disrupt the ionic bonds. If you add a heavy metal in there, it reacts with the sulfur-sulfur bonds, or the disulfide bonds, to form solids. And then if you agitate it, which means basically stirring it up, such as whipping, that stretches peptide bonds until they break. Know the different levels of the proteins. Primary is the strand of amino acids, it's the sequence. Secondary, you have alpha helix, beta pleated sheet, or triple helix. Know the difference between those three. Alpha helix, it uses hydrogen bonding to turn itself, and it twists around like a strand of hair. A triple helix is three of those wrapped together. Beta sheet also uses a hydrogen bonding, except it kind of creates like a bifold. It goes in and out. Tertiary is our protein folds that compact into a three-dimensional shape. Tertiary and quaternary are considered globular because they basically look like a big glob when you're done. And then quaternary are two or more of these tertiary structures globbed together. A Zwitterion has a charged NH3+, so the NH2 added a hydrogen, and then the COOH lost a hydrogen. So you have a positive end and a negative end. It forms when both the NH2 and the COOH groups and an amino acid ionized in solution. Has both a positive and negative charges and called a dipolar ion. The positive and negative cancel each other out, so the overall net charge is still neutral. It's still 0. Okay, here's an enzyme. Here's the active site of the enzyme. The substrate comes in. It's being held together by the same interactions as up here with the hydrogen bonds and the disulfides and so on and so forth. The salt bridges are holding it intact. And then that allows it to do the reactivity, and then the products leave and the enzyme's left over for it to happen again. Finally, know the difference between water-soluble and fat-soluble vitamins. Water-soluble vitamins are essential for normal health and growth, are soluble in aqueous solutions due to the presence of the alcohol groups and the carboxylic acid groups. They act as cofactors for many enzymes. So the only way for your body to function properly is to have that cofactor there for the reaction to occur. They are not stored in the body and easily destroyed by heat, oxygen, and ultraviolet light, so therefore you have to continue to ingest them. Fat-soluble vitamins, including A, D, E, and K, are soluble in lipids. They're nonpolar because they're nonpolar. They're soluble in lipids, and they are not soluble in aqueous solutions because, once again, they're nonpolar. They're important for vision, bone formation, antioxidants, and blood clotting, and they are stored in the body. It is possible to OD on fat-soluble vitamins. And that is the last of your review. for the final. Good luck with studying.